In this video, what we're going to do is we're going to take a look and determine the intervals of concavity up and concavity with respect to going down. And what we're going to do is we're essentially going to use the exact same process as what we just did for the first derivative test, except now we're going to use the second derivative. All right, so let's get to it. First derivative, all right, this is step one. That's going to be 8x cubed minus 6x squared. Because we're looking for concavity, we're going to find the second derivative, which is going to be 24x squared minus 12x. We're going to find the critical values, right? So we're going to find the critical values of the second derivative. And this is really easy because all we have to do now is just factor out a 12x. That's going to leave us with 2x minus 1 equals 0. And now we set 12x to 0. We set 2x minus 1 to 0. And from here, we can just go ahead and divide by 12. And one of our answers, or one of our critical values, is 0. And then we're going to add 1 to both sides. And then we're going to divide by 2. And so the other critical value of the second derivative is going to be 1/2. So just like we did in the previous examples, we find critical values. Second step, sign chart. We have two values. We have 0 and we have 1/2. If it's helpful, label infinity and label negative infinity. Or sorry, positive infinity over here, and then negative infinity on the left side, excuse me. And then what we can do is we can just pick some test values. Our test values are going to be fairly easy. So -1 is a good number to pick between negative infinity and 0. 1/4 is a decent number to pick between 0 and 1/2. And +1 is a value between 1/2 and infinity. We are now going to substitute those values back into the second derivative. Right? So be careful. We're now using the second derivative test. So if we do so, and this isn't too difficult to do. So our second derivative, remember, 24x squared minus 12x. So that's going to be 24 times -1 squared minus 12 times -1. Right? That's going to be 24 plus 12, which is 36. We don't care about the number, we care about the sign. And so what that means is between negative infinity and 0, it's not increasing, but it's concave up. Just as easy, we can substitute 1 back in. And I'm just doing the easy ones first. That way I don't have to go back to the calculator. 24 minus 12 is 12, which is clearly greater than 0. So that means we have a concave up right here. And so we would initially suspect that we're going to get a bunch of negatives here. All right, so let's plug it in our calculator and let's see what happens. So I'll quit out of here and we're going to get 24 times 1/4 squared minus 12 times 1/4. And that gives us negative 1.5. Right? So indeed, our suspicions are upheld. So this is going to be negative 1.5, which is clearly less than 0. All right, so what does that mean for us? Well, that means that for a couple intervals, right, that means that we're concave up, which means that the function is going to hold water. And then for one interval, it's going to spill water. Okay, so we're going to say that this function is concave up, and we're going to go back up here from negative infinity to 0, and then from 1/2 to infinity. Right? So we're just looking right here where we have our positive values. So that's negative infinity to 0, union 1/2 to infinity. And then where is it concave down? Well, there's that really small interval from 0 to 1/2 to where it's concave down. And hopefully that makes sense. We're doing the exact same thing that we just did for the first derivative test, except now we're using the second derivative test. And by the way, this is step 3, where we're interpreting the sign chart. Right. So we'll take a look at one last example. And the last example we're going to take a look at is being able to use a transcendental function and trying to use this second derivative test to determine concavity with